Hello everyone, I'm Alexandre Chapo and I'll be your host for today's webinar. On behalf of Furukawa, we welcome you to the webinar, High-Speed Copper Cabling CAT.6A, CAT.7, CAT.7A and CAT.8. Which you choose? Copper cabling has evolved a lot in recent years. There are many options of models and different categories of cables that often raise doubts when choosing the most suitable for each project. In this presentation, we are going to evaluate the difference between all the models available on the market and indicate which of the categories best suits each project and application environment. I present you my colleague Daniel Saad, who is an electronics engineer graduated from the Catholic University of Santiago del Estero. He started at Furukawa in 2017 as part of the trainee program and today works as product and application engineer for structured cabling in Argentina. During the presentation, please feel free to ask questions in the comments section. We will address them at the end of the presentation. If you'd like to schedule a meeting with Furukawa to learn more about our solutions or talk about any of your projects, you can click in the button Schedule a Meeting and we'll get in touch with you soon. Okay, Daniel, please take over.
Thank you, Alexandre, for that introduction, and thanks everyone for joining us today on this seminar. Our goal will be to take a look into the evolution that twisted pair cabling has undergone over the last years, an evolution which is, of course, related to the continuous changes made on Ethernet standards, which are used, as we all know, in telecommunication networks for data transmissions. As I'm sure you also know, copper cabling, which is the subject of today, is used in LANs, local area networks, meaning that we usually use copper cabling to interconnect devices which are placed within a limited area, such as a residence, a school, a hospital, or an office building. Now, according to the kind of applications running on our network, we will have to choose one of many different categories available for copper cabling, and among the choices we have CAT.5, CAT.6, and so on. But before we delve into that, let me give you a brief corporate introduction to those who are new to Furukawa. So Furukawa Electric is a Japanese company founded over 140 years ago. The Furukawa Electric Group in particular covers many business segments such as electronics, automotive systems, energy, light metals, and telecommunications, to name a few. And as of today, Furukawa has 120 subsidiaries and affiliate companies across Japan, Europe, North and South America. Now, as part of that group, Furukawa Electric Latam has been running in the Latin American market for 40 years now, beginning with our HQ in Brazil, but expanding from there to other countries, both in South and Central America, and all the way up to Mexico, where our newest production plant was opened a few years ago. Furukawa has more than 50,000 employees around the world. We meet the requirements of all three ISO certifications mentioned in the present slide. They refer to quality management systems, environmental management, and occupational health and safety management systems. And our entire operation is based on 4 core values. Solidity, because we have managed to build a reliable structure. Knowledge, which we have gained over the years through a deep understanding of both technology and market trends. Innovation, because we are in constant pursuit of improvement, and of course experience, which is in the end the greatest source of learning. And our telecommunications solutions, our telecommunications portfolio can be divided into 2 main categories, FCS and FBS. FCS stands for Furukawa Connectivity System, and this is where we stand today, because under this name we will find solutions for LANs and everything that has to do with indoor cabling systems including, of course, twisted pair cables with all the necessary accessories. And then we have FPS, which stands for Furukawa Broadband System, providing solutions for telecom companies and internet service providers aimed at MANs and WANs, metropolitan and wide area networks. But okay, let's move on to today's topic. And we're going to start by addressing the most important technology employed nowadays in LANs, which is, of course, Ethernet. Ethernet is a family of computer networking technologies. It was first introduced in 1980 and then standardized in 1983, so we could practically say that it has a 40-year history. And since its very inception, the Ethernet standard has been continuously updated and refined to support higher bit rates, a greater number of nodes, longer distances, but still retaining a good deal of backwards compatibility. Now, the roadmap we have on screen right now shows the evolution of the Ethernet interfaces over time. So, beginning in 1983, the first interface standardized was that of 10 megabits per second. Back then, Ethernet was not the only technology which was available for LANs. There were others, such as Token Ring or FDDI, as its main competitors. FDDI, in particular, stood out for using optical fiber as its underlying physical medium, but then it was still rendered obsolete in local networks in 1995 by what was called fast Ethernet, which offered the same speed of 100 megabits per second, but at a much lower cost. And eventually, of course, in 1988, it was also rendered obsolete by Gigabit Ethernet. Now, these three standards that I just mentioned, they are still in use today in local networks by the hosts, such as, I don't know, computers, printers, VoIP telephones, cameras, because these devices use those interfaces given that the speed and the bandwidth that they offer meet the requirements imposed by the applications running on them. You can also see that there was a considerable jump between 1998 and 2002. Standards went from 1 to 10 gigabits per second, and the 10 gigabits per second standard was a result of a demand for higher speed in small enterprise data centers. And you may also see here that we have in between two other standards, 2.5 and 5 gigabits per second to be more specific. We could say that those are rather new since they came about in 2016 so as to offer intermediate speeds between gigabit Ethernet and 10 gigabit Ethernet. They are commercially known as multi-gigabit, and they are mainly employed by some wireless devices. We'll get to that shortly. From 2002 onwards, Ethernet standards continued to be updated, reaching speeds of 40, 100, and even 400 gigabits per second, meeting the needs of the so-called hyperscale data centers. Now, this roadmap shows some of the past, it shows the present, but also the foreseeable future, because as demand for higher speed is not expected to cease, new standards will be developed accordingly. But high-speed copper wiring, which is today's subject matter, has its own limitations regarding distances, bandwidth, and so on. And as depicted here by the picture, 40 gigabits per second is the fastest we can expect to transmit data over a twisted pair cable. Beyond that, we will have to turn to fiber optic cabling, which is another subject altogether. All right, so talking about main applications, these are some segments that make use of LANs. Each one of them has its own requirements. For example, in an industrial environment, we will have all sorts of sensors, maybe recording the behavior of some desired variables and sending that information forward to some monitoring center where decisions will be made based on that information. Now, traffic running on this segment is usually considered to be narrowband, meaning that devices use interfaces that range from 10, to 10 megabits per second. You may stumble upon some device with a gigabit Ethernet interface in an industrial environment, of course, but the actual bandwidth needed doesn't happen to be as high as it is, for example, in an enterprise environment where we deal with internet connections, IPTV, IP telephony, and high density Wi Fi systems. So in enterprise premises, we are talking about fast Ethernet or gigabit Ethernet, which are, like we said before, standards from the 90s, but still in use today. Now, moving on to education premises. Again, we are talking about the same applications as in enterprise premises, only Wi-Fi services now are vital, and that's why we are specifically mentioning Wi-Fi 5 or Wi-Fi 6. Wi-Fi 6 is, as you may already know, the latest wireless standard launched. It handles multiple devices and it's able to deliver a lot more data to each of them simultaneously. And because of these applications, the interfaces in this case, we could say that range from 1 to 2.5 gigabits per second. Another segment has to do with healthcare. Let's consider, for example, a hospital, and we'll see an example further on, but medical imaging or vital signs monitoring for clinical analysis are maybe only two of many applications we could mention that will require to send information to the doctors responsible to making some decision, and that information has to arrive in as little time as possible. And of course, we couldn't help but mention telehealth, which is the distribution of health related services and information via telecommunication technologies, allowing long distance patient and clinician contact, something we could just not do without given the present circumstances. Now, for all these services to work properly, interfaces will require higher speeds of about 10 gigabits per second. And finally, speeds beginning at 10 gigabits per second and onwards, all the way up to the fastest ones existing today, around 400 gigabits per second. They are almost exclusively meant for data centers, where we will have a much higher density of traffic than that in a local network due to all the data processing that takes place there. But for this sort of premises, we recommend you opt for some fiber optic solution rather than twisted pair cabling due to the copper limitations we mentioned earlier. All right, so taking into account everything we've just discussed regarding Ethernet standards and different applications running on different segments, when the time comes to design our network, a very important part of it has to do with selecting the correct cabling system. And undoubtedly, the most used medium for transmitting data in local networks nowadays, especially in what we call horizontal cabling, is the copper or twisted pair cable. As its own name indicates, this kind of cable transmits data using four twisted pairs of copper wiring, making a total of 8 wires. And the higher the twisting rate, meaning the more twisted the pairs, the better the transmission gets and the wider the bandwidth as well. And that is where all these different categories appear. These different standards appear. The physical construction of the cable differs, allowing different bandwidths and therefore different applications. So the question is, how do we choose the cabling system that best suits our needs? And like we've been saying, of course, we do it based on the applications we need to run. So this is a table summarizing the most significant features of each category available in copper cables. You will see that the widely known names of category 3, 5, 6, and so on, they are derived from standards published by the Telecommunications Industry Association, the TIA, which operates in North America, while the European International Organization for Standardization, the ISO, calls them Class C, Class D, Class E, and etc. And I'd like to turn your attention to the fourth column where we have the Ethernet standards supported by each category. Now, these configurations are bound to work provided certain conditions are met. These conditions are listed in column number 5, and they have to do with distances. Basically, the permanent link, which is the link between the telecommunication outlet and the horizontal cross-connect, mustn't exceed 90 meters, and the channel, which is the permanent link in addition to the patch cords and the equipment cords, shouldn't exceed 100 meters. And so long as we comply with those conditions, we can use the configurations shown on this table. Now, CAT.3 was heavily used in the early 90s for wiring homes and offices. It's still used in two-line phone configurations, but has largely fallen out of favor for wired networking, thanks to the superior performance offered by CAT.5e. CAT.3 can be relied on to handle data speeds of 10 megabits per second, but no more of that. And then there came CAT.5, which isn't listed here for reasons that will become clear in the next few seconds, but CAT.5 overtook CAT.3 as the Ethernet cable of choice for LAN networking. It was designed for characteristics of up to 100 megahertz and was used for networks running at 10 or 100 megabits per second. But then, by twisting the pairs more tightly, they were able to eliminate some undesired crosstalk effects. Crosstalk has to do with electromagnetic interference, and the elimination of these effects allowed for more speed at which to transmit information, and that brought about CAT.5e, where the E stands for enhanced, given the fact that it is an improvement on CAT.5. CAT.5e is faster than CAT.5 because it was made to support gigabit speeds. And as a side note, and that's why this is in red here, but in 2016, when the new 2.5 gigabits per second standard came to be, CAT.5e was also found to support that particular application. In like manner, CAT.6 is an improvement on CAT.5e. It was first designed to support gigabit standard as well, but with frequencies of up to 250 megahertz, which considerably improves the network performance. And though it was not initially designed for it, should we need to work with the 5 gigabit per second standard, CAT.6 will indeed support it. Moving on, CAT.6A is capable of supporting data transfer rates of up to 10 gigabits per second at a maximum bandwidth of 500 megahertz, and this is probably one of the main arguments in favor of installing CAT.6A infrastructure because it will make your network future-proof. If you plan your cabling system to have a lifetime of, I don't know, 10 years or more, you should definitely go for CAT.6A. CAT.6A is also backwards compatible with CAT.6 and CAT.5e, thanks to them all using the RJ45 connector. Do remember, though, that speeds will always be limited and will perform to the lowest category cable or connector installed in the link. But going back to the connector, this RJ45 connector has become the standard connector in all network devices. If you take a look at your laptop, at your printer, IP telephone, access point, or even your switch hub or router, you are bound to find an RJ45 connector. And this is of great significance because you must have heard of what is commonly referred to as CAT.7 and CAT.7A. Strictly speaking, CAT.7 and CAT.7A do not exist as such, since there are no standards published by the TIA designating them as such. CAT.7 and CAT.7A are the commercial names given to standards Class F and Class FA published by the ISO. And we'll make a brief comparison between CAT.6A and CAT.7A shortly, but do note here that in terms of speed, there really is no improvement, and the fact that they use non-RJ45 connectors in itself is, we could say, a great disadvantage. Finally, CAT.8 is available in two different versions. We have 8.1 and 8.2, only the former using RJ45 connector. It was designed for applications ranging from 25 to 40 gigabits per second, so it's used almost exclusively in data centers. But there are a few considerations here that we will mention a few slides ahead. Now, this is an example regarding the healthcare segment where the network has a direct impact on time to diagnosis. So on the right side, we have the typical file size of different sorts of medical images. So take, for instance, this is an example using a file of 150 megabytes. And the question is, how long will the transmission time of such a file be? And of course, it will be up to the Ethernet standard employed by the network and by the devices on it. We agree on that, but the physical link also does have its own limitations, and I want to focus on that for a minute now. So if we had installed CAT.5e cabling, it would take our network as long as 3.5 minutes to transmit the file. But had we chosen CAT.6, that time would be reduced to 22 seconds, and with CAT.6A, it would go down to 2.2 seconds. And if you look at the table on the right, we are talking about a PET scan or perhaps a CT scan here. Imagine if we were to make calculations about applications related to, let's say, cardiology or radiology, where files can be 300 or 400 times as big. All right, so we're now going to focus on CAT.6 and CAT.6A because these are the ones that we promote and encourage you to choose should you be planning a cabling system infrastructure. We've already argued that CAT.6 is a considerable improvement on CAT.5e. Furukawa's CAT.6 solution is called GigaLAN. These cables can transmit data up to 1 gigabits per second along 100 meters, but remember they are also suitable for multi-gigabit compatible devices, meaning that this speed can rise to 5 gigabits per second if needed. It is recommended, we recommend it for enterprise environment, for enterprise premises. Our CAT.6 cables available come with LSZH jacket. LSZH stands for low smoke, zero halogen. You must have heard of it. It's a compound that offers two great advantages over traditional PVC. On one hand, the fumes given off in the event of a fire are significantly reduced. On the other, it contains no halogens, and so the toxicity of the gas is quite low. And keep in mind that smoke and fumes can be more of hazard than flames themselves in the early stages of a fire. So LSZH cables are safer for both people and the environment, and that's why many industries have seen an increasing demand for them. Along with the cables, we have all the accessories needed for installation of the entire channel. So we have patch cords, a patch panel, and of course our keystone jack, which in particular allows a cable insertion angle of either 90 or 180 degrees in the same part number. Then we have GigaLAN Augmented, which is Furukawa's CAT.6A solution. Data rate now reaches 10 gigabits per second, again in distances of up to 100 meters, making CAT.6A the best choice for backbone cabling and data centers, as long as we are going for copper wiring, of course. Again, our CAT.6A cables are also manufactured with an LSZH jacket, and our portfolio includes all the necessary accessories, patch cords, the keystone jack, consolidation points, and even also pre-terminated trunk cables, which are formed by a 6-cable bundle. They can be assembled with either male or female connectors, and it is ideal for plug-and-play installation. So you will notice that unlike CAT.6, which was a UTP cable, the one on the screen right now is an FUTP cable. And you might be wondering why. Why is that? What's the difference between them? So you know that TP stands for twisted pair, and then we have the first letter, which indicates the type of overall shield, while the second one indicates the type of shielding on each pair. So Cat6 cable was a UUTP cable because it consists of 4 unshielded twisted pairs and no outer shielding. However, for Cat6A, we recommend FUTP, which is a cable with 4 unshielded twisted pairs but containing an outer foil shield. And this is due to a phenomenon called alien crosstalk, which has to do with electromagnetic interference. Alien crosstalk has no real impact on Cat6 cables, but it can cause many problems in high speed, high bandwidth applications. And this is because noise sensitivity increases at higher frequencies, such as 500 megahertz, which is the highest frequency of Cat6A cabling. So we could say that there are basically two ways to reduce these undesired effects. One of them would be to manufacture the cable with this sort of, let's say, slotted jacket. You can see it here on the right. This would provide the cable with some level of immunity, enough to operate properly, but at a high cost because we would have a cable with a diameter of 8.4 millimeters. Instead, we were to just use a foil as an overall shield, not only would we get high immunity against this alien crosstalk effect, but we would wind up with a cable almost 1 millimeter smaller in diameter, and as a plus, it will even be lighter in weight. And that's why we recommend FUTP over UUTP when it comes to Cat6A cabling. This graphic will provide you with an idea of how each one of them perform regarding this alien crosstalk effect. So as you can see, they are both within the acceptable limits established by the standard, which would be the red line up here. But the shielded cable manages to considerably boost immunity to alien crosstalk when compared to the UTP. What about CAT.7? Data rate is once again 10 gigabits per second, just as it was with CAT.6A. Therefore, it could also be used for backbone cabling and data centers. But while there is a slight improvement in performance due to its handling higher frequencies, there are a few issues that need consideration. First, working with higher frequencies means the cable needs additional shielding. In this case, it will be an SF-UTP. So in addition to the foil we had in Cat6A cables, we will now have a screen over that foil. Since Cat6A and Cat.7A are designed for the same kind of applications, we'll make a brief comparison between them. Firstly, we just mentioned that extra shielding, which will be necessary. And this extra shielding, the screen over the foil, will make the diameter of the cable become larger. We will end up with a larger cable. Now, remember that when designing our cabling system, we have the TIA 569 standard, which sets the requirements of pathways and the spaces. And regarding trays, It specifically states that the maximum fill ratio of any cable tray can't exceed 50%. Therefore, the larger the cable diameter, the smaller the number of cables we can place inside the tray, or we could also say that the larger the cable diameter, the larger the trays we will need to use. Last but not least, CAT.7 employs, as we've said before, a non-RJ45 connector, unlike the vast majority of network devices. This means that in the end, we will most likely have to use an RJ45 connector, which will probably be a CAT.6A connector, in order to connect our devices to the network. And remember that the standard also says that performance of a certain channel is always limited to the lowest category in any of its components. So to attain the full advantages of CAT.7 higher performance, you would need a special connector. The one we have here, it's called GigaGate 45. But the thing is, you would not be able to plug this connector into any of your network devices. So using a CAT.7 cable with a CAT.6A connector will make our channel perform as though it was a CAT.6A channel. So there really is no point in using CAT.7 cabling. Then the latest technology in copper cabling is CAT.8. Earlier we said that it can operate with frequencies of up to 2000 megahertz and that it reaches speeds of up to 40 gigabits per second, but that there were a few considerations to be taken into account. Well, these considerations basically have to do with distances. While standards for all other categories were defined for a channel of up to 100 meters, CAT.8 was defined for a channel of only 30 meters, with a permanent link of 24 meters and 6 meters worth of patch cords. Then we have another limitation, which has to do with the number of connections. Only 2 connections are allowed within the channel, so consolidation points are no longer an option here. And these limitations, along with the fact that it's designed to operate at such high speed, means that CAT.8 is almost exclusively intended for data center applications. Still, bear in mind that this is an FFTP cable where each pair is individually shielded by an aluminum foil tape and then another tape is applied over the cable core. So this results in a cable with a particularly large diameter and quite as heavy as well. So if you're going to work with speeds of 40 gigabits per second, we recommend you go for fiber optic cabling. And finally, there's one more thing that I would like to address before we wrap this up. It has to do with CPR. CPR stands for Construction Products Regulation, and it's basically a classification system for construction products created by the European Union with the aim of proving the safety of buildings. Since cabling systems are designed to be installed permanently within residential and commercial buildings, they are subject to the CPR. So manufacturers are obliged to manufacture and market the products in agreement with the standards indicated in the CPR. The CPR standard has been designed to determine the likely spread of fire through a structure, and as cables run throughout buildings between floors and through walls, they are, of course, a natural conduit for the spread of fire. Now, this regulation classifies products into one of 7 classes. They are called Euro classes, according to the table you can see now, but only 5 classes apply to cables. The classification criteria define the fire reaction performance of cables. It even contemplates the possibility that the manufacturer, lacking requirements related to fire reaction, can use the FCA Euro class here at the bottom, which refers to undetermined performance, rendering the cables, of course, unsuitable for indoor public spaces because no fire protection level at all can be guaranteed. Then we have the non-flame propagator Euro classes. They are ECA with a basic reaction. This is what we would call a standard cable. Then we have DCA with improved reaction, CCA with reduced reaction, and B2CA with low reaction. For this set of low fire hazard cables, there are some additional classifications that can be specified. They are listed here on the right. They have to do with smoke emission properties. That has to do with information about the amount and the opacity of the smoke which is emitted. Then we have the flaming droplets or burning droplets with information about the dripping of burning material during the fire, and finally the acidity performance with information about the emission of acid gases during the fire. Now, it's up to the designer or to the installer to satisfy themselves that the products chosen are appropriate for the application and that they meet any contractual requirements. So, whenever specifying cables, take care to assess the risk of fire within a building and the potential ease of evacuation. Each application, I don't know, a hospital, a prison, a tunnel, an airport, a building, they all offer their own unique challenges and they should be assessed individually. Also, take into account that in some parts of Europe, the national regulatory body is defining which class is to be used in a specific application. In any case, safety should always be a priority, and we encourage you to design your cabling bearing this in mind so as to provide a risk-free environment. So this concludes the focus of discussion today. I understand we do have a few minutes though, in case you have any questions or comments.
Thank you, Daniel. Yeah, we still have a couple minutes to answer a few questions. Let's see here. Okay, so one of the questions is which flammability class should be considered for the cables in LAN networks in general?
All right, so as we've said before, LANs are local area networks, meaning that they have to do with wiring cables within closed spaces where we will have a lot of people around. So I would go for, and I've said before that Furukawa's cables, both in Category 6 and CAT.6A, come with LSZH jacket, low smoke and zero halogen. And I would definitely go for that because it prioritizes safety both for people and the environment. The amount of smoke which is emitted by that kind of jacket is considerably lower than any PVC jacket, and then the toxicity of the gas is also reduced. I encourage you to search. There are many interesting videos online, even on YouTube, that you could find with comparisons between burning an PVC jacket and an LSH jacket. And as people say, an image sometimes is worth more than 1,000 words. So
Thank you, Daniel. I think we already passed a bit our timing. So if anyone has any other questions, you can also send them directly to Daniel's email, or you can also click on the schedule a meeting button and we will get in touch with you soon to talk about any doubts or curiosity you might have about Furukawa solution or any project that you might need assistance. And this webinar uh, later on will be, after it's finished, you'll receive a link of the video and that will stay available for you to watch again. Okay, we thank you very much for participating in this webinar and we hope to see you again on the next ones. See you soon.